Welcome to my friends. Now today's lectures we have discussed the topic carbonyl compounds. In this topic we are going to discuss the reactions with aldehyde and ketone. Now first reactions we have seen are here the reactions with sulfur. In these reactions this acetone can treat with sodium bisulfate to form the adduct. This name is acetone sodium sulfate. The attack of NaHO3 occurs through sulfur, which is better nucleophile as compared to oxygen. The adduct is identified as sulfonates, that is sodium bisulfite compounds. Now similarly, this benzaldehyde can treat with sodium bisulfate and to get the adduct as a benzaldehyde sodium sulfate. So this is a sodium, that is NaHSO3. It is a good nucleophile, and this good nucleophile attack on this carbonyl carbon and to form negative charge on oxygens. And this negative charge on the oxygen can pick up the proton this and to form the. So such a type of adduct will get the result. And the sodium bisulfite compounds are crystalline, therefore they can be separated by filtration and they can be decomposed by acid to get back to aldehyde or ketone. Now we are going to discuss the next reactions with the Grignard reagents. Do you know that Grignard reagents are alkyl magnesium halides. This is called as a Grignard reagent. In the Grignard reagent, the negative charge and magnesium has positive charge, right? So number of reactions can we have studied like RMGX. This R is an alkyl group. They will carry the negative charge. Magnesium carries positive charge, and therefore Grignard reagents they undergo nucleophilic addition reaction. Then after hydrolysis with dilute acid it produces alcohol. Now C is here. This is the Grignard reagents, which is nucleophile attack on this carbonyl carbon and to form negative charge on oxygen are here. So O minus, then positive Mg are here. So O minus MgX. And then after hydrolysis we dilute acid to convert O minus convert to OH and remaining plus MgOH MgX. It is byproduct. Now see how will you prepare these primary alcohols by using the Grignard reagents. Those aldehyde can treat, that is a formaldehyde, and this is a Grignard reagents. It is a very simple reactions as like this CH2 minus Mg plus, right? CH2 minus Mg plus Br minus. It is a Grignard reagent. So this CH2 minus attack on this carbonyl carbon and to form negative charge on oxygens are here. So this is a O minus MgBr. And then after hydrolysis of those adduct with H3O plus to get the corresponding alcohol. So this is alcohol is a primary alcohol. Similarly, we have prepared secondary alcohols, but in place of formaldehyde, we are use the acetaldehyde, right? And therefore, those Grignard reagents CH3, CH2, MgBr, we can treat are here in dry ether, which are very important. The Grignard reactions carry out only in a dry conditions. So those Grignard reagents CH3, CH2, MgBr. So CH2 minus Mg plus. CH2 minus is attack on this carbonyl carbon, form negative charge on oxygens. So O minus Mg Br. After hydrolysis with acid, Then O minus convert to OHR here. This is the byproduct. Now similarly, also we have prepared the tertiary alcohol as like this. But one more examples. Now we have see are here like a benzaldehyde can treat with this magnesium, methyl magnesium iodide. So this methyl carries negative, right? This methyl carries negative charge. So this methyl is attack on this carbonyl carbon and form negative charge on oxygen, right? So O minus Mgi. And then after hydrolysis with the acid to convert O minus convert to OH, right? Similarly, now prepare the tertiary alcohols. But last slides we have see the prepare primary alcohols. Then we are use formaldehyde. If we are prepared the secondary alcohol, then we are use acetaldehyde. And if we are use prepared a tertiary alcohol, that times we are used in place of aldehyde as a ketone like a acetophenone. Similar reaction can be done like this. This methyl magnesium iodide, so methyl carries negative charge, attack on this carbonyl carbon and to form negative charge on oxygens. That is O minus Mgi. And then after hydrolysis with water to get O minus convert to OH. All the reactions are similar as like to prepare primary, secondary and tertiary alcohols. But in place to prepare primary alcohols, we are use formaldehyde, and we are prepare secondary alcohols, we are use acetaldehyde, and we are prepared tertiary alcohol, that time we are use ketone. Similar other reactions, that is methyl magnesium iodide can treat with this ketone. Then this CH3 attack on this carbonyl carbon and to form negative charge on oxygens are here. So O minus Mgi, this adduct. And though these adduct are intermediate which on hydrolysis with water to get O minus convert to OH. This is a byproduct. Next reactions, the reactions with alcohol. So this aldehyde can treat with alcohols. So when aldehyde can reflux with alcohol in presence of this HCl gas, they undergo addition and to give an intermediate, right? Give an intermediate. So these intermediate are named as hemiacetal. And this undergoes substitution in another molecules of alcohol to give the acetal, that is geminal diether. For example, those acetaldehyde can treat with alcohol in HCl gas. So this lone pair of these oxygens attack on this carbonyl carbon and to form O minus convert to OH by after the protons to form the hemiacetal. Those hemiacetals can treat with HCl gas to convert this OH replaced by OET. So another alcohol molecule can add to this carbon to form diethyl acetal of acetaldehyde. Now other reactions like this, the reactions can reversible and therefore excess alcohol used to shift the equilibrium right hand side. So aldehydes and ketones use such acetals or the ketal depending on the acetaldehyde we are used to form the acetal, and we are used the ketones to form the ketals. So this ketone can treat with ethyl orthophosphate. So this ethyl orthophosphate to form ketals like this, right? Similarly, the other reactions like this, the acetaldehyde that is acetaldehyde can treat with this ethylene glycol. So this two OH is there. So one of the OH is attack on this carbonyl carbon, form the OH. Then second OH is attack on this carbonyl carbon and replace this the new forming OH and to form cyclic acetal in presence of HCl gas. Right? In place of this acetaldehyde, we are use the ketone to form kettles, but which kettles? Cyclic kettles. So this reaction can be, we have seen here, we are use acetaldehyde to form acetals, we are use ketones to form kettles, then we are use the ethylene glycols in presence of acetaldehyde to form cyclic acetals, and in place of ketone to use our then form the cyclic kettles in presence of HCl gas. Next reactions, now we are going to discuss the reactions with amines. Aliphatic and aromatic amines react with aldehyde and ketones to give an intermediate compound called as the carbalamine, right? This is a carbalamine. Then this carbalamine, first step is a nucleophilic addition of the amine to the carbonyl group and to give an intermediate compound, and then after the presence of an acid, the carbalamine undergoes dehydration and to gives unsaturated compound which is called as the N-substituted amine, like this after removal of water molecules. So this hydrogen and this OH can replace as water molecules, form the carbon-carbon, double bond is here in between carbon and nitrogen. So this is N-substituted amide, name is a benzylidene amine. So another carbonyl compounds like ketones, that is acetone, can treat with this ethylamine. Then what happens? The lone pair of this nitrogen attack on this carbonyl carbon and to form the negative charge on oxygens. Negative charge on oxygens. So pick up the protons from one of these hydrogen and to form OH. And then after formation of the OH are here and NH is there. Then what happens? So those protons and this OH can replace as water molecules to form this carbon and nitrogen having the double bonds are here. So name is a isopropylidene ethylene amine. Isopropylidene ethylene amine. Right? This is another type of amines reaction with acetones. Next reactions. Now C is here like this. This is one of these ketones, and this is a amines like piperidine. So this piperidine can treat with this to form this salt, that is a lone pair of those nitrogen is attack on this carbonyl carbon, form negative charge of the oxygen attack the protons, attract the protons to form OH. So write this OH is here, lone pair of this given, so this is positive charge are here. So from this carbon and nitrogen double bond. So name is a iminium salt. This OH and H can replace. So to form iminium salt. Right. Next reactions as like this another aldehyde, that is a propanaldehyde, can treat with diethylamine. Then this lone pair of the nitrogen is attack on this carbonyl carbon, form negative charge on oxygens, and therefore O minus can pick up the proton from this to convert OH, right? This OH, and then after this no hydrogen on the nitrogen is left for the removal of water molecules, and hence those hydrogens and OH can replace. So this type fashion to form this carbon-carbon double bond in between these two carbons and replace the OH as a water molecule. So H and this OH remain removal of water molecules. So new types of amine can form called as a enamine. It is not amine, it is a enamine. Right. Now next type of reactions we have see are here the condensation type of reaction. Condensation type of reaction, it means that the two molecules are condensed with each others. It means the two different molecules. So first type of reactions we are see here reactions with phenylhydrazine. Reaction with phenylhydrazine. This is a phenylhydrazine EHNH2. Phenylhydrazine. So in general, this aldehyde and ketones reacts with phenylhydrazine on heating to form the crystalline product is called as a phenylhydrazone derivatives of this aldehyde or the ketones. As like this, for example, those having aldehyde or ketones and phenylhydrazine can condense with each other. So this lone pair of these nitrogen attack on this carbonyl carbon to form negative charge on oxygens. The O minus pick up the protons from this, so convert O minus to OH charges like this. So this is a one of the hydrogen is left. This is a NH, and then removal of water molecule. This OH and this H, right? This OH and this H removal of water molecules to form carbon nitrogen double bond here. So name is a hydrazone derivative. Similarly, you can treat with this benzaldehyde in presence of phenylhydrazine. So these two hydrogens and oxygens. 1 minute. This is oxygens, and two hydrogens. Removal of water molecules and to form benzaldehyde. This is a benzaldehyde. So benzaldehyde phenylhydrazone derivative. Similarly, we can treat with the acetophenone. So this acetophenone and these two hydrogens removal of water molecules and to form the compound is a acetophenone phenylhydrazone derivatives. Next molecules now we are seeing here. This is acetone and this is a phenylhydrazine. So these two hydrogens and this is oxygens. So removal of water molecules like removal of water molecules and to get acetone phenylhydrazone derivatives. Next reactions we can see are here like the reactions with 2,4-DNP. This is another name is 2,4-DNP. 2,4-DNP. 2,4-DNP means 2,4. Okay? 2,4-dinitrophenylhydrazine. So 2,4-DNP. It is short form 2,4-DNP. 2,4-dinitrophenylhydrazine. Similarly, those 2,4-DNP can treat with this benzaldehyde to form the compound is 2,4-dinitrophenylhydrazone derivatives. 2,4-dinitrophenylhydrazone derivatives. So how will you form these two hydrogens, right? And this is a oxygens can replace and to form the phenyl 2,4-dinitrophenylhydrazone derivatives. So next reactions we are C is here reduction of aldehyde and ketones. Reduction of aldehyde and ketones. You know that the reagents of lithium aluminum hydride role, it mainly used for the reduction of these aldehyde and ketones. So how will you this reduce? It is a very strong hydride reducing reagents. It reduces aldehyde and ketones to corresponding alcohols. The reaction mainly carried out in dry ether or THF, tetrahydrofuran, at room temperature, because it is violently reacts with water and alcohols, and hence they cannot be used as a solvent. In first step, what happens? The one molecules of lithium aluminum hydride simultaneously add the carbonyl group of 4 molecules of the aldehydes, right? 4 molecules of aldehyde reacts with the 1 molecules of the lithium aluminum hydride to form this complex. After formation of this complex containing the aluminum, in second step, those complex can hydrolyze with the dilute acid and to use alcohol, having the primary alcohols. Hence, the 1 molecules of lithium aluminum hydride simultaneously reduce the 4 molecules of aldehyde or 4 molecules of ketone into the 4 molecules of alcohol. Aldehyde is reduced into primary alcohol and ketone is reduced into secondary alcohols. Similarly, we see here this aldehyde, they will reduce to corresponding alcohol, that is lithium aluminum hydride are strong reducing agent. They reduce, it is CH2OH, 2 hydrogens will be added. One hydrogen will be this, second hydrogen this. So CH2OH, this is the product. CH3, CH2, CH2OH. Next molecules which are C is here. This CH3, CH2, this is a ketone, right? And now we have C is here. This ketone can reduce to secondary alcohol, right? This is secondary alcohol. Lithium aluminum hydride, dry ether, they will reduce this ketone to secondary alcohols. Similarly, lithium aluminum hydride, one more things which are very important. The lithium aluminum hydride only selectively reduce polar functional group as like this carbonyl group, like carbonyl, cyanide, nitro, but they does not reduce the non-polar functional group. They does not reduce the non-polar functional group like carbon-carbon double bond, carbon-carbon triple bond, or like benzene. So such groups cannot reduce by lithium aluminum hydride. They reduce only polar functional group, and hence in these reactions only reduce this polar aldehyde group to alcohol, like this. Now other examples, one more examples like this. This is a unsaturated alpha beta unsaturated aldehydes. In this reaction also, which are very important reactions, but in this reaction they reduce carbon-carbon double bonds are here, because it is a alpha beta unsaturated aldehyde or ketones. They attach to phenyl ring, they can reduce carbon-carbon double bond also. One more thing is very important, like this. If the carbon-carbon double bond is attached to methyl group, that times the lithium aluminum hydride don't reduce carbon-carbon double bonds. It only reduce carbonyl group to corresponding alcohol. But this phenyl ring is attached to these alpha beta unsaturated compounds or alpha beta unsaturated systems. That times the lithium aluminum hydride, they will reduce carbon carbon double bonds as well as this aldehyde group to corresponding alcohol. C is here. So carbon carbon double bond will be reduced as well as this carbonyl group will be reduced to corresponding alcohol. So this is very important to us to know about the role of lithium aluminum hydride. Thank you.